There are, I have to do superposition, but before that there are some still things are left. Almost, I think it is a lecture of oscillations we completed in 7 lectures, no? That's awesome actually. Almost it took me 20 days to complete in the classroom, whatever I have. Yeah. So yeah, basically like it takes time if you solve more questions now. But I completed with you in some kind of a hard number of questions, so that's why it took less time to complete. Means the concept got cleared easily. Okay. So now I have used this, means we have done this a little bit, but let us just once again revisit this. Yeah, series and parallel, yeah, connection of spring, right or not? Okay, now let us just think about that. Now we know that we can connect the kind of springs in either series or either in parallel way. In both the case, we can connect it, isn't it? So first, we'll try to understand how the series connection happens. Okay, right or not? So let us just see some series connections. Now let's suppose if I have a spring and with this I attach another spring, and with this I attach a block, okay, of mass m. Now this is of a spring constant K2, this is of a spring constant K1. Now let's suppose if I expand it, then there will be two spring forces which will be present over here or not. The most important thing is, let's suppose if I consider this as my reference point, this I am considering as my reference point. Or let us just consider that for the each and every spring I am defining its natural length, word or not. So let's suppose if I expand it, wait 1 minute, what will happen? Let's suppose this spring got expanded till over here, this spring got expanded till over here, and the block is over here now. Now look over here, when you will see that it's, let us suppose this is its natural length. Okay, for both of them this is their point of natural length. Okay, so this got expanded by some distance x1. The first spring, since the spring constant is different, so it will be stretching different, isn't it? And this got extended by some another distance which we call it as x2. So look over here, if this is k1 and this is k2, so net displacement is how much? X net is equal to x1 plus x2 or not? How much is that? X net is equal to x1 plus x2. Now, if this is my net displacement, you only tell me there are how many kinds of spring forces? There are two spring forces. First one is over here, Fs1, and then there is another spring force which is Fs2. So we have two spring forces over here. Now, whatever happens, if if I just try to understand what is the net force or something like that, so try to understand that for first spring Fs1, 1 minute, sorry. The first spring Fs1 generates an spring force of minus kx. Sorry, 1 minute. Let me just take the same variable. This is, yeah, that will be much more fine. Otherwise, we'll be stuck in the dilemma. This is Fs2. This is Fs1. So Fs1 will be minus of kx1, k1x1 or not. Are you able to get me? Similarly, the spring force 2 will be what? Minus of k2 x2. Got it or not? But look over there. If I see these two springs, then the net force will be balanced by my F external or not. In the case of equilibrium, yes. Yeah, means there, if there is an F external, void or not, you only tell me. Like if there is a yeah, means can we say that this spring force one, although their values of K1 and X1 are different, K2 and X2 are different, the net spring force between them is always same because they are joined together and they are moving in one direction. Then we know that according to constraint relation of the springs, all these points will feel a same amount of force, isn't it? Got it? So now, if I write x net will be what? Any one of the spring force Fs, I call it as Fs. What do I call it as? Spring force Fs. So x net will be Fs by x net, means that will be 1 k net or not. If I write x net equation will be what? Simple, multiplied with k net into x net is equal to spring force. Are you able to get me or not? Minus of k x net actually. So this will be minus, that will be x1 will be minus of Fs by k1. Similarly, x2 will be minus of Fs by K2. So you got a relation for the net spring force that 1 by K net is equal to 1 by K1 plus 1 by K2. Are you able to get me or not? Is that clear? So that's my equation for net spring force. Now, if there is only one block, then we can write the time period equation. Then time period will be what? 2 pi root under m by k net, basically what? K net, or you can say that k net is the k of series connection. Which connection? Series. Is that clear or not? Are you able to get me? मेरी बातें समझ में आ रही हैं? Okay, a series combination is of kind of one type only, and vertical also you can see like this will be attached like this way. Got it or not? But let us just talk about the parallel one. In parallel there can be many arrangements possible. Okay, I'll show you some of them. Parallel connections. Okay, then let us first derive that equation, then we'll see to understand what can be the different possible diagrams. Okay, so this is one of the simplest parallel connections which we see in everyday common uses, that this is my mass m. Now if you look over here, if you see that the elongations, so if I just try to stretch it, if you will try to stretch it, what will happen? The stretch in both the springs would be what? Same or not? Stretch will be what? Same, right or not? Although their spring constants are totally different. Is that clear or not? Means if this was of K1, this is of K2, then from this point, from this certain mean point, the expansions in both of them should be x naught, and that is same, isn't it? Which is, we call it as displacement in spring, which is similar. Are you able to get me? Understood? Is that clear now? Now let us move to next point, that let's suppose if I take up this series combination or something, sorry, if I take up this parallel combination, then if I found the spring force, so spring force 1, let's suppose I call this as first one, this is second one, so here I'll have Fs1, here I'll have Fs2. So spring force 1 will be minus of K1 x naught, spring force 2 will be minus of K2 x naught, isn't it? Are you able to get me or not? So the net spring force, ध्यान से देखो, the net spring force is just equal to spring force 1 plus spring force 2 or not? Because there are two blocks on which two different forces of spring are occurring or not. F net will be what? K net. But the displacement is still remains same, which is x naught. So minus k net into x naught. This is minus k1 into x naught minus k2 into x naught. So you got the k net relation, that is equal to minus k1. Sorry, not minus k1 plus k2. So net spring force in terms of parallel connection is just like a addition of the spring constants. Are you able to get me or not? Is that clear? So that is what we try to say in regarding this. And if you find the time period in this case, then time period becomes once again 2 pi. Only one block is k net in parallel. Are you able to get me or not? Now, basically, there can be many arrangements of this kind of cases. Actually, one of the cases which usually comes in the exam and usually people gets confused over here is this kind of arrangement. Okay, that there is mass m from this side. Huh. So once again, look over there. This is also a kind of which kind of connection? Parallel connection. Yeah. Because look over there, try to understand. Let's suppose if you displace this by x naught distance, so whatever is the compression, that is the expansion in this spring or not. So does the same length is appearing with two different distinct kind of two different kinds of spring forces? Are you able to get me or not? But in case of, remember that, yeah, in case of series connection, these displacements will be totally different. कैसे रहेंगे हरदम? Yeah, okay. Next, I'll take another example of that. Let's suppose there is a vertical same kind of arrangement of spring. Then this is also a kind of example of which kind of connection? Parallel. This is also a kind of parallel kind of connection. Are you able to get me or not? Is that clear? So let us try to solve some questions regarding that. You know that one of the fact that if we, let's suppose, uh, if we cut the spring, let's suppose there is an, if a spring of spring constant k and length L is there, and length L is there, then क्या होता है रिलेशन? स्प्रिंग कांस्टेंट k is inversely proportional to 1 by length of the spring. Are you able to get me or not? मतलब if you increase the length, the spring constant decreases. If you decrease the length, the spring constant increases. Is that clear or not? So basically, let's suppose if I have a spring, I think that I have done in this work energy power chapter, isn't it? So if there is a spring of a spring constant K and L, and I just cutted that spring into, uh, like I just cut it into three different parts, and I asked you that find the K dash for the length which is L by 3. So what is its new? 3L or 3K? So how much this will become? 3K. Are you able to get me or not? So means whatever is the cutting ratio, the K dash becomes as it is. Is that clear or not? Is that clear? Okay, so can I just move ahead? Chalo. So based upon that, you can do many kind of questions, many kind of diagrams will appear. They just ask about time period or something like that. So I think it will be easier to solve for you. Or should I solve some questions? Should I give you one question? Let us. Okay, let us just try one question regarding that. One minute. Sorry. So there is one spring, then there is another spring. Yeah, it's easy. It's really easy. And the spring constants are K1, K2, and K3. The question is find the effective time period. I have to teach you. I have to teach you solids or fluids. Okay, solids is done for you. So should I do solids first or fluids first? Okay then. Mm-hmm. Yeah, I'll do right now after that waves only. That is also a time taking thing. It consists of sound waves, string waves. Mine, why it is taking me to complete it? Because I have to teach you both NEAT and J. Sorry, both NEAT basically. So that's why it becomes time taking. K1 and K2 are parallel, of course. Yeah. Mm, try करो. हाँ सीरीज में हाँ सही सही आइडिया. हाँ. हम्म. You try that. हाँ. Did you got it? Did you got it? Mm-hmm. Okay, let us solve. Okay, in first case, K1 and K2 is in parallel connection, isn't it? So first case, parallel effective, K effective in parallel. I call it as K dash. Let us call this as K dash. So that will be how much? K1 plus. Now total effective if I found out. So 1 by K effective. Now that whatever is coming as parallel is a kind of series with K3 or not. The K effective of these two parallel is in series with the K3. So it will be 1 by K3 plus 1 by K1 plus 1 by K2. So this implies K effective becomes how much? K3, K1 plus K2. I'm writing it directly. बस हो तो गया आंसर. Then time period is 2 pi root under 1 mass by K effective, which is K3 K1 plus K2 into K1 plus K2 plus K3. That's all. That's your easiest question. Is that clear? Easy peasy. Bus. Okay, so we'll move to next part. Means I'll give you a worksheet related to this. You just try to solve it or solve HCMA questions. Okay. हाँ हाँ और मैं एक दो क्वेश्चन और करवाऊंगा बट नाउ लेट अस जस्ट सी द वन ऑफ द मोस्ट इंपॉर्टेंट केस which we call it as basically defining the time period of a simple pendulum. So we have studied SHM till now, but we studied for the blocks, isn't it? We studied for the spring mass system, but actually SHM is also performed by what? A simple pendulum or not? So give the heading time period of simple pendulum. ठीक है. अब ध्यान से देखो. अब एक बात बताओ जो पेंडुलम होता है मैं मालूम है in case of pendulum what happens that if I have any kind of a pendulum then this pendulum oscillates. Okay, let's suppose I have this as bob which has mass m and length of the thread is l. Then also for this pendulum also there are two main conditions that it has extreme point होगा ना. इसका एक खुद का एक extreme point होगा है ना. and this pendulum oscillates between these two extreme points. Are you able to get me or not? Now let's suppose these extreme points happen to be at angle theta. कितने एंगल पर हो रहे हैं? थीटा एंगल। मान लो इधर का कंसीडर करते हैं, तो हमें मालूम है कि मीन्स दिस इज इट्स मीन पॉइंट, and here its velocity is zero, here its velocity is zero, when it returns here its velocity is maximum, isn't it? अब ध्यान से देखते हैं, अगर हम ध्यान से देखें तो बेसिकली फॉर दिस पेंडुलम during circular motion also I have taught that the tension works in this direction and the weight is along downward direction, isn't it? Yeah, so basically we can resolve this weight component, will not resolve the tension component. So at the extreme, wait. I'll tell you. Like we can resolve tension also, but the answer will come as same. No problem regarding that. So look over here. This pendulum is oscillating in like this fashion. Take. This is my tension. This is my weight mg. Tension I can also resolve. It's of no problem, but it will not provide us anything. What we are looking for is something. Sorry, as you know that we'll tell you later. 1 minute. This is mg. This is theta. This is mg cos theta. This is mg sin theta. When we were doing that, we were resolving tension because we wanted to find the equilibrium condition. हम क्या निकालना चाहते थे? Equilibrium और velocity निकालना चाहते थे ना, है ना? लेकिन यहाँ पर क्या है? हम निकालना चाहते हैं force. With which force it is trying to oscillate? Is it really the tension? No, tension is balanced by mg cos theta or not? So which force is actually oscillating it? It is mg sin. Yeah. So basically, the in if you try, अगर ध्यान से देखो, तो in case of simple pendulum, in case of simple pendulum, basically our restoring force means the force which brings from left, means अगर कोई बॉडी लेफ्ट में जाए तो उसको राइट लेकर आना है ना, और कोई बॉडी राइट में है तो उसको कहाँ लेकर आना है? लेफ्ट में। तो यहाँ पे वो फोर्स की तरह एम जी साइन थीटा वर्क कर रहा है नहीं कर रहा? Yes, so till now, see, we have in SHM we studied that the restoring force is equal to F is equal to minus of kx. But the restoring force over here, in case of simple pendulum, which makes it oscillate, ठीक, वो अपन का क्या है भाई? Simple सा, that is equal to mg sin theta. Which one is that? mg sin theta. Are you able to get me or not? So basically, can we say that the f is equal to minus mg sin theta? Now, once again, if we look over here, let us consider the theta to be small. Theta कैसा मान रहे हैं हम? Why not? Why not? You look over there, the body whose the velocity was made zero because there was a downward force of mg sin theta or not. So actually, the displacement was of this direction, but the particle's force is working in which direction? Backward direction. So that is why let us consider the theta to be of a small approximation. Then this force will be equal to how much? Minus of mg sin theta will just change to theta or not? Are you able to get me? But what is theta? Can you tell me what is theta? Mm-hmm. Can we say that let us just, yeah, if this theta is small, then this angular arc is just like a straight line over here or not, which we call it as y, and let us call this length of the thread to be L. So can I write sine theta in terms of what theta as y by L? Got it or not? What I'm writing? Perpendicular by base, hypotenuse. Are you able to get me or not? If theta is small, the curvical arc will feel like that's just a displacement in the x direction. Is that clear or not? So then once again, the force equation reduces to minus of mgy by L or minus of mgl by 1 minute. Let me just separate it. Minus of mg by L into y. This is just like equation of pendulum as spring force or not. where we compare with f is equal to minus of kx. Are you able to get me? So what we can write of acceleration equation? Basically, can we write the acceleration equation also or not? Yeah. So m into, but this time acceleration will be what? d2 theta by dt square. What that will be? Yeah. So that is equal to minus of mgy by l. Mm cancel. And once again, this implies d2 theta by dt square is equal to minus of g by l into y. Then g by l can be treated as omega square or, so you got the angular velocity equation for the simple pendulum. Omega square is equal to g by l. This implies omega is equal to root under g by l, or time period is equal to 2 pi root under l by g, which is given as time period of simple pendulum. So therefore, time period of simple pendulum is given as T is equal to 2 pi root over length of the thread divided by effective gravity. Which gravity? Effective gravity. Is that clear or not? ठीक है? Is that clear? So let us just try to bring this into some kind of different kind of equations. I'll just give you some finding the effective length or effective something like that. Okay. So can you just tell me, means let us just think of these cases in the case of lifts. किस case में? After studying physics, you have started to hate lift. No sir, no more lifts. Okay, now I have three lifts. How many lifts? I'm not over yet. Let us just bring a truck also. Uh, 1 minute. I have four lifts. Okay. Pendulum, pendulum, pendulum. Each one has mass m. Mass is how much? This body, yeah, this body is going down with acceleration a naught. Length of the thread is same in all the cases. Masses are also same. This one is going with acceleration due to gravity. This one is going up with acceleration a naught. And this is going rightwards with acceleration a naught. Then if this is A, B, C, D, let us just think of it is going towards right. Then tell me in which case, then you have to tell me the time equations, time period of pendulum in each case. Easy peasy. Got it? Tell me what will be the time period in each case. I'm taking the class also. I'm taking class guys also. You guys are worst. Uh-huh. Tell me. You can displace anywhere. It's just you see that this time period is independent of angle theta. Word or not? Can you tell me what once again? There are these are four different cases. So pseudo force appears in four different ways in all these cases. Correct. Yeah, so you just think of where are the pseudo forces acting in each and every case, and then you just apply that. You are going to get the correct answer after that. Okay, just try it. Oh. Mhm. 2 minutes more. बनेगा or should I tell you? In first case at least. अच्छा एक बात हो, ध्यान से एक बात हो. In case let's suppose I'll just make you understand one of the case. Let's suppose if I'm taking the first case, okay? Take the lift is going downwards with an acceleration how much? A naught, isn't it? So let's suppose if the pendulum from its normal condition, which is over here, okay, the pendulum from this condition goes to some angle theta, tick. Length will never ever change, isn't it? Is length is going to change due to that? No, but something definitely changes. I'll tell you what. Tick. अब एक बात बताओ, the whatever is my mass over here, whatever is my mass over here, let's suppose I call it as mass m. So previously the weight was mg, isn't it? Previously the weight was how much? Mg. Now due to the pseudo force, there will be a, if the acceleration of the accelerating frame is downwards, this feels a pseudo force in opposite direction, which is m a naught. Is that clear or not? So basically, the net downward force over here, I can write it as what? I can write that as mg minus a naught because it is hanging vertically downwards, isn't it? So the tension T, basically my tension T, which will try to balance that, this angle will be theta. So the restoring force is how much? Mg minus a naught cos sine theta. Are you able to get me or not? So if the restoring force is minus mg minus a naught sine theta, then time period or just time period is what? 2 pi L by G effective how much? G minus N naught. That's your answer. Are you able to get me or not? So here it is. T is equal to 2 pi root over L by G minus N naught. Here the N naught value is exactly equal to G or not. So whatever is my weight components downwards, upwards is also how much? Same. So basically the body is floating in air. So time period is how much? Zero. It's not oscillating. It's not oscillating. No? It's not an SHM. Sorry, it's not zero. Time period is undefined basically. Yeah, because denominator is zero, no? Is that clear? Here, yeah. So here, mg is also downwards. No, that's not hypothetical. That is correct. If you are in air, for bird, can we define the time period? No, because they are in the air. So this time period in third case, this wait. In the third case, the A naught is downwards, mg is also downwards. So this become L by G plus A naught. This is my effective. gravitational force. Are you able to get me or not? Let us just discuss the fourth case, which is of this truck. Let us leave truck, whatever you wanna say, both are same. Okay. Initially the pendulum was this way. Okay. Now you look over here. If this goes with acceleration a naught, for this mass m, what will happen? This mass m will feel some kind of force in the backward direction or not? Yeah. So the mass m will be pulled back over here, isn't it? Now look over here. Mg works downwards, but the pseudo force is this time in this direction or not? M A naught. This is mg. So the net balancing force is what? Net balancing force is how much is that? That is, let's suppose if this is at angle theta, this is at also angle theta. So this will be m, uh, that will be root over, if this is one force, this is one force. So the resultant of that will be what? M square, a naught square plus g square or not, because cos 90 is 0. Are you able to get me or not? So basically, this force is how much? M outside root under a naught square plus g square. Is that clear or not? Understood. So then this force will have two components once again. One that will try to restore this, isn't it? So basically that is trying to restore. Are you able to get me or not? But the restoring means that is only given over there. Is that clear? Are you able to understand me or not? So once again, the G effective, if you look for the G effective value, so this G effective becomes how much? That's, if I write this equation, that is M root under a naught square plus G square into sine theta. Are you able to get me or not? So G effective is this term. So once again, time period becomes what? 2 pi root under L by a naught square root under of a naught square plus G square. That's my time period equation over here. Is that clear? Understood? मेरी बातें समझ में आ रही हैं? It's of basically we are mm, 1 minute. That's not that sine theta component. Let me just think of that. That's just uh, it's not that direction. It's not in that direction basically. Okay, so we are writing sine theta because definitely if it is getting pulled, although there is a chance that it will not get pulled. Okay, so let's suppose if I just, if this is my there, it has two components, one along that line only, one along this side only. Okay, okay. So basically, if, see, it's a very rare chance that it will oscillate. You asked a very good thing actually. That where is the sine theta component? So it's not getting resolved on the basis of sine theta. If this is that force, then I can resolve it like t cos theta, t sine theta. Are you able to get me or not? But how to say that? Okay, let us just make it oscillate. Means the chances of oscillating is very very less, right or not? ठीक है ना? But yeah, but let's suppose if it is oscillating, huh? Because if this pseudo force is coming over here, it will try to put that in equilibrium, right or not? Basically, what it will have to do is, yeah, Yeah, so basically you have to say that मतलब एक तुम खुद सोच के बताओ, if a truck goes forward, then whatever is in the backward direction goes backward and it stops over there or not. Okay, but if the if the truck's acceleration is fluctuating, then it will go forward, backward, and then it will oscillate. But yeah, so due to that, the G effective, which can work as a restoring force, will be this particular valve. Are you able to get me or not? No, no, I'm I'm saying you, what I'm saying you is try to understand. See, let us just see. Okay, this is my pen. Okay, let us just do it. This is mg. Okay, and this is m naught. Go ahead or not. So the net acceleration for this pendulum, where it is present, can you tell me? Yeah, the resultant is present where? It's in this direction only, na? Yes, and that resultant is exactly equal to how much? M a naught square plus, sorry, g square to the power of 1 by 2. That's यही है ना मेरा effective resultant force. But if this resultant force is not able to balance this tension, what it will do? It will try to oscillate. Let's suppose this thread is making some kind of angle theta over here or not. So definitely, what it will do, it if it is trying to pull it towards this side, if it is trying to, if it is not able to balance this tension, it will try to generate some kind of acceleration over there or not, and then the net torque will be created or not, and the body will start oscillating. Are you able to get me or not? So basically, that's what basically this question is solved on the basis of torque equation. क्या चीज के थ्रू सॉल्व करते हैं? Torque equation के थ्रू सॉल्व करते हैं. Are you able to get me or not? So we'll teach you that also, that how to solve the questions using the torque equation. Like for any kind of a bow of pendulum which is moving in a arc of a circle in vertical kind of plane. Which kind of plane? Yeah. So then we can say basically what happens is that, if remember that basically what actually happens is that the torque of this mg in these cases, torque of mg, if it is more, then it will oscillate only. Got it or not? It might feel like it might feel to us that the net force can be balanced by tension, but the net force, if the net torque of mg, you look over here, m naught is less, mg is more or not, because a naught is less than g. Are you able to get me? So then if the torque of mg will be more, what it will do, it will try to oscillate along this direction or not, है कि नहीं? तो यही दिक्कत है कि torque actually makes it oscillate. Is that clear? And that is why we are considering the G effective relation as A naught square plus G square to the power of 1 by 2. Now you got it. Mhm. So that is A naught square plus G square to the power of 1 by 2. So then let us just understand the pendulum case through the help of torque. Okay. Torque method. Got it or not? Now look over here. You know that if there is a simple pendulum, okay, and if it is making some kind of angle theta with the vertical, this is a bow of mass m, right on. Okay. If it is making some kind of angle theta with the vertical, then this m has two components. One is, means basically I can write it as mg. Now you look over here. If this is my axis of rotation, from here I am trying to rotate O. So for O, if this length of the thread is L, the torque about O is how much? Can you tell me? Look over here. The most better method is through the torque, because look over there. When you draw the tension is along the direction of radius. Torque is given as what? Tau vector is equal to R cross F, which is R into F sine theta, isn't it? So when you look over here, this T lies on the same line of what we say radius. So the net torque due to tension T is how much? Zero. So the torque is created by what? M only or not? Torque due to what? Tension into L. What's the angle between them? Zero. So what is that? Okay. When I will teach rotational, then I'll definitely do that. Okay. So torque, tension due to torque is how? Torque due to tension is how much? Similar to zero. Is how much? Zero. Got it or not? Now look over here. If I want to define torque, then one force is left, another force which is torque due to mg. So torque due to mg is what? Mgl. Now look over here. If I see, if this angle is theta, then the length vector and the mg makes angle theta with them or not. So what it will become? Mgl sine theta. Are you able to get me? Now once again, if theta is small, then I can write it as mgl into theta. What is torque? Torque is I into alpha, which is mgl. And basically, if you look over here, this torque is creating, if it is, it's kind of torque formula. Do you not remember? Moment of inertia. Yeah, so torque is equal to moment of inertia into alpha r naught. Now this is also a kind of restoring torque. Which kind of torque? Restoring. So the actual angular displacement is towards this side or not, but the torque is acting in which direction? Opposite direction. So this would be also what? Negative. Is that clear? Now I is what? I into alpha if I'm writing. So I alpha is what? d2 theta by dt square. यही होगा ना? अल्फा तो d2 थीटा by dt स्क्वायर ही होता है कि नहीं? तो that is equal to minus of mgl into थीटा. I क्या होता है? d2 थीटा by dt स्क्वायर. I जो है वो I is equal to mr स्क्वायर. यही फॉर्मूला पढ़ा है ना अपन ने? रेडियस तो L के बराबर है, तो माइनस mgl by ml square into theta. So look over here, L cancel, cancel. Once again you get the same relation, that d2 theta by dt square is equal to minus g by L into theta. So once again that is my omega square or not, which exactly matches with the previous case, isn't it? So basically you can find the torque for any kind of case using these two methods. The torque method is much more efficient and it will give the answer within less time, because the torque due to tension is always zero. Always it is zero. How much is that? Is that clear or not? So you can apply these relations and get the different equations of torque and all these kind of things. Okay. Okay. Now the main task was to discuss about superposition. Like we wanted to discuss. Let me just check if you just have, if you have any kind of doubt, you ask me. Till that I'll just search some more questions. If you have any kind of doubt till now, just please ask me. Mm-hmm. Yeah. Yeah. So, acha, one thing I left one more thing, and last thing is that, and that we call it as compound pendulum. What we call it as? Yeah, it's a simple harmonic motion only. Let us just understand this equation. First understand this, then I'll move ahead. Okay. Yeah. Okay. I'll. Actually, in circular motion, we came across this relation. Yes, isn't it? You only tell me. If I write alpha, alpha is radius into acceleration. Sorry. You say me. Let's suppose if I write. No. Actually, if I'm writing, that is another thing. Here we are writing omega square as g by l. You are confusing with any kind of equation. Got it? This is an equation. Here, basically, you said correct, sir. Can we just say that alpha is equal to minus of omega square theta? So that's kind of a weird equation. This is basically, yeah, basically this is SHM equation which we are creating. Got it or not? Kinematic equation is totally different. Kinematics follows F is equal to ma, but here we are following F is equal to minus of kx. Are you able to get me or not? Okay, so we are following a total different pathway, but although it involves the kinematics, but the pathway is totally different. Here you can't say that. But if you look into the dimension-wise basis, the answer is still same. Are you able to get me or not? Yeah, dimension-wise, it's totally perfect. It's nothing wrong. Dimensionally, it is totally perfect over here. Got it or not? Okay, so in rotational, you'll get to know how this happens and how alpha we write it as d2 theta by dt square. Okay, although you have studied, but when I'll teach, then it will be a good idea. Okay. Okay. Now let us just see compound pendulum. Now see, till now we have done the oscillation of a bob or not. Just the bob we have tried to oscillate, but think of one case. Let's suppose if I have any kind of a rigid body, this kind of a rigid body, and what we did with this body, we created a hole over here, and then I just attached one axis over here. What we attached? An axis. Then this, if I just try to oscillate it, this body will oscillate or not? This body will definitely oscillate. So when a rigid body itself oscillate with an axis on its uh, surface, then we call that particular thing as compound pendulum. क्या बोलेंगे उसको? Is that clear or not? So the definition is like when a rigid body, which kind of body? Rigid body is suspended from an axis, is suspended from an axis and made to oscillate, then we call it as compound pendulum. This definition would have not been given to you in your books or something like that. This चीज को क्या बोलते हैं? Compound pendulum. But we know that any kind of rigid body basically moves through its center of mass or not. So it's basically the point is basically this center of mass is trying to oscillate. What is trying to oscillate? So just like we consider the thread of the string, here we will consider the particular point of oscillation. Means this is my axis, this is my center of mass. Then we'll define the length of oscillation, just like the length of a string, as the gap between this axis and center of mass. Is that clear? So L is what? What is L? L is the distance between point of suspension, okay, and center of mass. Is that clear or not? Are you able to get? Totally, मेरी बातें समझ में आ रही हैं? Now you look over here. Then once again, here which thing is oscillating? Its weight is working downwards. But which thing is trying to oscillate? The weight component or not of the center of mass. Let's suppose if it was weight component is oscillating the center of mass. Is center of mass is what is the center of mass? Basically, it's a position or not. Is it a force? No. The force which acts at now got the idea. If this is theta, yeah. So once again, the torque of the mg sin theta will try to oscillate it. Is that clear or not? Okay. Now, sorry, mg sin theta. That's my torque. 1 minute. Torque is equal to r cross a. So minus mg sin theta into length L. Torque is I into alpha once again. Minus mg sin theta into length L. And since theta is small, so theta is similar to sine theta. So the equation changes as I into alpha is equal to minus mgl into theta. Are you able to get me or not? So alpha is what? d2 theta by dt square. That is minus of mgl by I into theta. But this time I is not similar to ml square, no? Because for rigid body if it depends because I depends upon the condition of rigid body है कि नहीं अगर मान लो तुम्हारा रिंग है तो रिंग के लिए अलग होता है आई डिस्क है तो अलग होता है आई इज दैट क्लियर और नॉट so I depends upon the rigid body that's why this is not getting I can't write I is ml square but in previous one since I was just exactly equal to for this mass m so I can be defined as ml square okay तो ठीक है तो टाइम क्या है इसका मतलब ओमेगा स्क्वायर की वैल्यू ये हो गई तो टाइम आएगा 2 पाई रूट अंडर दिस टाइम इट गॉट चेंज्ड आई बाय एम जी इनटू लेंथ एल दैट्स माय टाइम पीरियड इक्वेशन इन केस ऑफ which cases guys compound pendulum got it is that clear can I ask a question regarding that then should we do okay let us do one question बोल रहा है a ring is trying to oscillate ठीक this is my engagement ring okay a ring is there which is trying to oscillate with some kind of an axis which is kept over here and passing through the plane of the ring ठीक है मतलब रिंग ऐसे ऐसे कर रहा है ऐसे 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 जा रहा है okay the point is this ring has mass m okay and radius of the ring is r got it uh, then question is find the time period of oscillation if g is similar to pi square बताओ सॉल्व हो जाएगा ना. चेक इट. आई हैव गिवन इफ कंडीशन ना. अच्छा एक बात बताओ सुनो. If this is my ring, the axis is over here or not? The value of moment of inertia for the ring, which we write it as mr square. What we write it as? If the ring mass is m, then that is for this axis of rotation or not? So the axis got shifted by how much distance? R distance. So the if this is point O dash, the moment of inertia through O dash is given as what? Moment of inertia through center of mass plus md square, where d is the distance of shifted axis. So I O dash will be how much? Mr square plus mr square. How much is that? 2 mr square. Is that clear? Then time period becomes what? Yeah, 2 pi root under g by what is sorry I by what was that relation? mgl. Mg and L is what? Radius r. I can replace it. T is equal to 2 pi. I is 2 mr square by mg r cancel, cancel. G is exactly equal to pi square or not. So T is equal to how much? 2 pi into twice r by g. Is that clear? So it becomes how much? Twice r by g. So ध्यान से देख बोल रहा है. Then you can find the time period. Time period becomes how much is that? 2 pi cancel. That is 2 root 2 into under radius r. That's my time period. You can put the any value of radius r and you get the answer or not. Is that clear? अच्छा बोलता है कि in some questions like in JEE they asked that this ring was behaving like a second pendulum. Ring was behaving like second pendulum. Then find radius r. Word or not? अच्छा अब एक बात बताता हूँ. व्हाट इज द मीनिंग ऑफ फर्स्ट पेंडुलम एंड सेकंड पेंडुलम. अच्छा एक बात बताओ. कोई भी पेंडुलम है कैसे ऑसिलेट करेगा? ये एक यहाँ से यहाँ तक जाएगा, फिर यहाँ से यहाँ तक जाएगा, फिर ये यहाँ तक रिटर्न आएगा ना. यस. तो सेकंड पेंडुलम का मतलब समझो. बेसिकली जो ये जो ऑसिलेशंस हो रहे हैं, क्या हो रहे हैं? हाँ. तो if I just consider any kind of oscillation, then if this is if you can say that if from here to here, from here to here, then from here to here, then from here, means if it in this whole case the time was taken as 1 second, then we call it as first pendulum or simple pendulum. Are you able to get me or not? मतलब समझो जरा. मैं इस origin से स्टार्ट हुआ, फिर पॉइंट ए पर गया, फिर पॉइंट ए से कहाँ गया? अनदर एक्सट्रीम बी पर गया, फिर बी से ओ पर आया. तो यहाँ से लेके यहाँ तक ये जो जितना टाइम लगेगा, हाउ मच टाइम आई टेक फ्रॉम गोइंग फ्रॉम ओ टू ए टू बी, बी टू ए. देयर आर 4 quadrants or not, just like SHM. This is mean, this is extreme, this is also extreme. So if I take 1 second to go from mean to extreme, then another extreme to another extreme, and then returning to means if I return back to initial means initial point, then we call it as one time period or not. So if one time period is equal to 1 second, then it is called as simple pendulum. Means first pendulum. Are you able to get me? And if this one time period is equal to 2 seconds, how much seconds? Then we call it as second pendulum. क्या बोलेंगे इसको? ठीक है? Is that clear? So you can say that time period of One minute. Second pendulum is how much seconds? 2 seconds. How much seconds? 2 seconds. So you put it over here. T is equal to how much? 2 is equal to 2. Root 2 into radius r. 2 got cancelled. So that implies 1 by root 2 is equal to root radius r. Take the square on both sides. So 1 by 2 is equal to radius r. This implies radius r is equal to 0.5 meters. Is that clear or not? So how much radius is required to become a second pendulum? 0.5. Is that clear? Hmm. So then there are 2 to 3 more questions. So you tell me one thing, like the oscillation of fluids, like there are some cases of, yeah, we have to understand that also, like these kind of cases, like you have a YouTube and the fluid is oscillating. I think that will be better to do in fluid mechanics, correct or not? Actually, your fluid mechanics is kind of okay. I'll do that in fluid mechanics. That's a better idea. Okay, so this was all the cases. I'll do means you leave after these 2 pages. How many pages? Yeah, when your exams will be completed, we'll solve more questions related to this. ठीक है? 2 pages. हाँ, 1, 2, 3, 4. Okay, and then we'll do that. Before going, I'll just discuss one more question because I want to solve some more hard question. Okay, that's a pending lecture, and we'll start from tomorrow directly waves. And in that, in one lecture, we'll go through the superposition. Afternoon? No, it's not possible. Why? Tomorrow is Monday now. Okay, we'll see then. No problem. Okay, let us just try to think. This was one of the best question which I found it out. It was telling that let's suppose uh, we have you know we have springs, two spring. One is of spring constant cannot, another one of spring constant 2 cannot, and these gaps are present. Okay, means the masses are not attached. Basically, if they even compress it and when they are returning back, they are able to lose the contact. And the question is, find the time period of SHM. बताओ. You think, is it a parallel connection? Is it attached? First of all, then it's not a parallel connection. Think why I should tell. Hmm. Tell me. Neither series, neither parallel. It's an unattached spring. Think of one case. एक बात बताओ सुनो पहले. जब ये oscillate करेगा, what is the meaning of time period? We mean that going from extreme to mean to extreme, then once again extreme to mean, once again from mean to once again extreme, and then extreme to mean. So there are four parts of a time period, and include all these four parts, then it is a one time period equation. Are you able to get me or not? That is the question. Now, if this mass starts from here, it goes to left first. It travels how much? L naught. Let's suppose it travels with some kind of speed V naught. With what? The first time it takes is how much? L naught by V naught or not? Tell me how much is that? L naught by. Yes. Now think of one case. Next, it will compress the spring, and then it will once again return back. But is it going to expand the spring? No, no. For the half of the spring means for this case of the spring, it is only doing half of the time period or not? Listen, this spring was at its natural length. Try to understand. Oh shit. This is my natural length. This get compressed. This returns back. Then it will leave the contact or not? The block leaves the. Is it? Is it going to expand? Yes. So mean to extreme, extreme to mean. But what about the other half? Not possible. So it's just doing half of the actual oscillation, right or not? So its time period will be what? T of the first spring 2 pi, one block, 1 minute. Write it perfect. What? How come it is just pi? 2 pi root under m by. Yeah, basically it will be divided by 2. Correct, correct. So T1 will be pi root under m by how much? Cannot. Okay. Now once again it will return back, isn't it? Once again it returns back. Once again it will take the time. T is equal to second time L by L naught by V naught. See, for the linear displacements, mean for the displacements which are not there with the spring, time is measured with the kinematics equation. But the with the attached case, the time period is measured like this. No, none of these equations are applied. What means? But I'll tell you why I'm writing the equations. What I'm trying to say is, let's suppose if this is my mean point, this is my extreme point according to SHM, or I do not use the spring, I do not use what? So then the body will do just the kinematics motion or not. So if this gap, listen me properly, if this gap is of length L naught and this is of also length L naught, then the time period in first case here T naught will be just L naught by V naught. Then for the return case L naught by V naught. Then from here to here L naught by V naught. From here to here L naught by V naught. So total time period for this oscillation without the spring is 4 L naught by V naught. How much is that? But for the case of spring, it's just equal to one time period, which is 2 pi root under m by k. Did you understood? Uh-huh. Compare means, yeah, you just mention it. You just mention in your notes the time period in case of SHM. Okay, there are two cases. body moves between extreme point and mean point and extreme point, and here the body was performing SHM. Here the body was just moving due to some external forces also. Slowly it was moving, okay? So if it goes with velocity v naught, and here also if it goes with some kind of velocity v naught, then here the time is given as 2 pi root under m by k, where spring is used. Here what is used? Of spring constant k. And here I have to define the length first of all. Then the time period for slowly moving case is it is 4 L naught by V naught, because here the motion is happening without spring. Is that clear? So try to understand the time period. What we are defining: time period going from mean point to extreme point, returning from extreme point to mean point, going from once again mean point to extreme point, and then once returning back. So for that the total time period in this case is 4 L naught by V naught, but here it is how much? 2 pi root under m by k. So here once again it goes back, so T naught L naught by V naught, once again it goes from here to here, T is equal to L naught by V naught third. Then it will compress the spring T2 of the spring, which appears as once again half of the actual spring, because it's not expanding is, so 2 pi by 2 root under m naught by m by twice k naught, 2 2 cancel, T2 is equal to pi root under m by twice k naught, and if it returns back, T is equal to L naught by V naught. So total time period of oscillation is pi root under m by k naught plus 4 L naught by V naught plus pi root under m by twice k naught. That's my total time period of SSM. Is that clear? Hmm. 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 There is a reason without SHM, and then there is a reason with the SHM. Okay, got it? So you have to see what is actually there. You have to not always pick up directly and put the things. You have to see the things and then you have to tell about the answers. Okay? Okay, na? Chalo, फिर. So we'll meet with the waves tomorrow. Tomorrow we are going to start what? Waves. Got it? Okay, we'll take that. If I'll be free, then I'll tell. Okay? Okay, you just see tomorrow if there will be any kind of possibility, I'll just take a 15 to 20 minutes. I'll clear that HC Verma doubts and these two doubts. Okay, whenever you are free, just attend for 15 to 20 minutes. Okay, that will be good now. And now you will be able to solve some more question of HC Verma. Ask those doubts also. Okay. अरे थोड़ा सा ही हार्ड है, ज्यादा हार्ड नहीं है. अब no 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 you wait. Oh, 1 minute. Hmm. SHM was chapter number 11, 12, I think so. Yeah. So all the things from here is only done except this. Yeah, all these things are done. Phasor diagrams, energy, angular simple harmonic motion, which we discussed today. Okay, simple pendulum, time period of the simple pendulum. Simple pendulum as simple harmonic oscillator. Okay, determination of G is not there. Physical pendulum, which we also call it as compound pendulum. One is left, which is torsional. We'll discuss it tomorrow. Okay, and then this particular thing, superposition, but we'll do superposition at one go. Superposition of waves, superposition of SHMs, and all at one time. Is that clear or not? Okay. And damped is in not in your syllabus. Please check if that is in your syllabus. You tell me tomorrow. Okay. Okay. Now. So these are the cases like which we were discussing. Elastic cases today, which we discussed. It's a combination of normal case plus the case of the. So it will see that the answer is 12 by V, pi root under m by k. Why pi root under m by k? Because it is doing half of the oscillation. And 12 by V because it goes that and returns back. Yeah. Okay. Uh, is that clear? This is the question you can try. This is a good question. Friction. It will come as requirement of the friction from this equation. Okay. If you will not be able. Yeah, actually I'll solve it. Try this question. This one is already done. Two block system, if you will be able to solve it, try. The two parts of the question I have left, 12 and the 13 one. The two block system and the gravity one. Okay. When that's why I told you to leave two pages, okay? Because I want to discuss these two parts little bit later on. Okay. Yeah, yeah, I'm telling, I'm going on that. Did you try this objective one and objective two? Try this question for short answers, then objective one, then objective two first. Okay. Question in this, which question is that? This question we discussed, I think so. Question number 14. Which question? Okay, so it's easy peasy. If you think so, it's totally easy. Which, okay, we'll see that then. Okay.